Hello everyone. Let us see the working of a digital storage oscilloscope in detail. Now, so what is a digital storage oscilloscope or a DSO? DSO is an instrument that analyzes the signal digitally and stores the data in the electronic digital memory. By examining the stored traces in memory, it can display visual as well as numerical values. It digitizes the input signal in order to have subsequent digital signals. The input is stored in direct memory in the form of 0 and 1. This stored digitized signal is then viewed on the CRT screen after the signal reconstruction in analog form. Here, the digital copy of input waveform is stored and further analyzed using digital signal processing techniques. The maximum frequency that can be measured by using digital oscilloscope basically depends on the sampling rate and nature of the converter. Sometimes people misconstrue in between digital voltmeter and digital storage oscilloscope. Digital voltmeter records fluctuation in voltage. In contrast, digital oscilloscope displays a graphical representation of the signal. It also helps to determine unexpected voltage source. So this is a block diagram of a typical DSO. It has a preamplifier, a trigger circuit, then we have the control logic, ADC, memory, DAC, and the analog signal is fed to the CRT where we get the voltage displayed. Okay. So the CRT employed in the circuit displays the data stored in the electronic digital memory. From this memory, the data is sent to the CRT. As the data in the memory is stored in digital form, so here we required a DAC to convert the data in the memory to an analog signal. So the signal is reconstructed in analog form in order to be displayed on the screen of the CRT. So now let us see the working. So from this figure we can see that an analog input signal is fed to the preamplifier unit. So this unit amplifies the input so as to raise the level of the amplitude of the signal. So the amplified signal is then fed to the ADC and the trigger detector. Okay. So the voltage crosses the threshold value. The device starts recording on the application of the signal sent by the trigger circuit. The output of the preamplifier is sampled by the ADC at regular intervals. The digital output provided by the ADC is stored in the memory at consecutive locations. So the recording of signal continues until this memory is full. The DAC employed in the circuit produces analog signal to be displayed in the CRT. Any further changes in the input re-triggers again will re-trigger the oscilloscope, which causes the memory to be reset. That means the memory is overwritten with the new upcoming data unless the system is in hold mode. By the application of hold mode, the signal traces can be analyzed by the user according to the user's choice. So the size of the memory unit determines the number of samples stored in it. One can alter the length of recording by changing the sampling frequency of this ADC. In case of digital oscilloscope, many different input channels are used. Okay, so the memory available to each channel gets reduced. When all the channels share a common store, this is done through a process called as multiplexing. So 40 channels oscillator are obtainable commercially, having a storage capability of 25,000 dots. So many oscillators employ floppy disk storage capability. At the time of digitization, at the time of digitization, in order to make sure that no information is lost, according to sampling theory, the sampling rate must be twice as fast as the highest frequency of the input signal, failing of which will give rise to the aliasing effect. So, although the input is sampled according to sampling theory, aliasing effect can still occur. So this is because the output is present as series of dots that corresponds to the sampled value. Okay, you can see the series of dots here. Okay, so the DSO uses interpolation technique for visualization of final waves. So without interpolation, your output will be in the form of series of dots. So after interpolation, you can create a new data. So interpolation is a technique that creates new data points with the help of discrete set of known data points. So the interpolation may be of two types, linear interpolation or sinusoidal interpolation. So this is the output of linear interpolation and this is the output of sinusoidal interpolation. So you can see clearly here that the dots are not disturbed. Okay. So linear interpolation, the dots are connected together by a straight line. It can be used in pulsed or square wave generation but not in case of sinusoidal waves. So sinusoidal interpolation, the dots are connected so as to form a sinusoidal waveform. It is not suitable for square or pulse waves. So sampling technique gives rise to another problem when used in DSOs. The transient or glitches that exist in between the sample points can be missed out. So this problem is solved by envelope mode oscilloscopes. The envelope mode oscilloscope employs special logic circuitry due to which the sample and digitizing circuitry run at high speed, the functioning of which is independent of the setting of display time. The advantages of DSO: the storage time is infinite, it can be operated easily, and there is flexibility of the display property. So the applications of a DSO: it is used in audio and video recording, it is used in radio broadcasting for signal testing, it is used in circuit debugging for testing the voltage of the signal. So this is all about digital storage oscilloscope. Thank you for watching the video.